Hello everyone, welcome to today's webinar. Today we're going to look at the second section of the last unit in Algebra 1, Algebraic fractions. And today we were going to look at how to add and subtract algebraic fractions. This is myself. My name is Miriam. I'm your math instructor here at Penn-Foster. I teach high school math in the state of Pennsylvania, and I also have my master's degree in education. Today in this webinar, we're going to look at the most challenging topics in the second section of the sixth unit of Algebra 1. During this webinar, we're going to have self-check questions that follow each section of our webinar today. And those self-check questions are not graded. Those questions are provided to you to assess yourself and see if you are able to do a question yourself, or if you're not, then you may want to reach for help, or maybe go back to the study unit, or maybe you want to ask a question. Your questions, of course, are welcome. Please keep them relevant to what we are speaking about within this webinar. And all registrants, of course, will receive a recording of this webinar, whether you attend today or you were not able to attend with us today. As I said, today we're going to look at adding and subtracting algebraic fractions, and to do that we need to also learn how to find the least common denominator between two algebraic fractions. So let's have a review, a refreshment of how did we add or subtract regular fractions with no variables, nothing, as far as algebraic fraction, just regular fractions. How did we add or subtract these numerical fractions in the past? So the rules that we went by for adding or subtracting fractions is that if both fractions are like fractions, or if they have the same exact denominator, then we just go ahead and keep the denominator the same, but add the numerator. So for example, question number 1 here, if you see, if I'm going to add 3 over 5 plus 1 over 5, 5 and 5 are the common denominator. I don't have to find an LCD for that. So I'm going to go ahead and add the numerator. 3 and 1 is 4, but keep the denominator the same. We do not add 5 and 5 is 10. So our final answer in this case would be 4/5. Now, if we look at the second question, 6 over 14 plus 8 over 28. Now, those fractions are not like fractions. They are unlike fractions. We are not able to add or subtract unlike fractions as is. We need to switch at least one of the fractions. So both fractions will have a common denominator. And of course, in that case, at least one fraction will have its numerator changed. And then we're able to do the operations, whether it's addition or subtraction. So for example, we need to think about the 14 and the 28. We need to think about how can I switch 14 to 28. We know that 28 is a multiple of 14, meaning that if I multiply 14 times a factor, which is 2, I am able to change this 14 to 28. And this is what I'm looking for, to switch the two fractions to equivalent fractions, and at the same time, these should be like to each others. So since I'm going to multiply the denominator times 2 to make it 28, I have to do the same thing on the top. Multiply the 6 times 2. And then let's rewrite the question. 6 times 2 is 12. Over 28, because 14 times 2 is 28, and then I have still to add plus 8 over 28. In this case, I'm back to the first example here. We have the same denominators, keep the denominator as is, but add the numerators. 12 plus 8 will give you 20. Now, in our algebraic fractions later on, we'll see that sometimes we have to simplify our answer to put it in simplest form, like the thing that we're going to do here. We have 20 over 28. We have common factors between 20 and 28. We have to eliminate those factors. By looking at those numbers and by reviewing our multiplication table, we know that 4 is a common factor between 20 and 28. Then we need to eliminate that factor by dividing over that factor. So 20 over 4 is a 5, and 28 over 4 will give you 7. Your final answer is 5 over 7. This is again just a review of how we used to do addition and subtraction with numerical fractions. Subtraction, it's the same thing, the same rule. I have different fractions, different meaning unlike fractions, then I'm going to try my best to change the 4 to 12, multiply times 3, and multiply times 3. Rewrite your problem, 11 over 12, and now it's going to be minus 9 over 12. And then keep the 12 the same because it's the common denominator. 11 minus 9 will give you 2. Again, we have to simplify our answer, divide over 2. Divide over 2 because you want to eliminate the common factors. 1 over 6 or 1/6 is the final answer. So that was back in the days when we were have to add only fractions with numbers. What would we do if we need to add or subtract algebraic fractions? And algebraic fractions, again, are just fractions, but instead of having only numbers, we may have variables. We may have variables raised to exponents, like you see here. Now, before we go ahead and actually add the two algebraic fractions, I thought to take it step by step and first learn how to find a common denominator between two given algebraic fractions, because this is usually the most challenging step in adding or subtracting, is to find the common denominator between the two unlike fractions and also correctly change the numerators accordingly so they stay equivalent to the original problem. So when we look at the two fractions, our goal in our mind, like we used to do with numbers, is to change the 9ac to the fourth and 27c to the second to the same denominator. How can we do that then with variables being part of our denominators? The way we're going to think about it is we're going to look at how can we multiply both fractions or both denominators, to be specific, so they are identical. For example, the first denominator has an a, the second denominator does not have an a. Then I have to multiply the second denominator times an a, so both denominators have an a. So the first factor I'm going to multiply the second denominator times would be an a. So I'm going to write down the denominators, only the denominators. So 9ac to the fourth, and also I have 27c to the second. I'm going to also use color coding. I'm going to try to keep up with that so we're able to identify the factors that we use. So we said we're going to multiply times a. And again, the reason is the a appears in the first denominator but not in the second denominator. So we need to bring in the a to the second denominator. So multiply the second denominator times an a. Now, that's not the end of that. We see that one denominator has a c to the fourth. The other one only has c to the second. So if I multiply the second denominator times another c to the second, and if you multiply c to the second times c to the second, remember when we multiply the same variables with different exponents, you add the exponents. So 2 and 2 is 4, and that will bring you back to the c to the fourth that appears in the first denominator. And again, we're trying to make them appear the same thing, exactly the same denominators in both fractions. Okay, so far, let's rewrite then the second denominator here. So far we have 27 c to the fourth a. The first denominator, we did not change that yet, 9ac to the fourth. So the variable part in both denominators are identical. Now the numbers are not. I have a denominator with a 27 and another denominator with a 9. How can I change the 9 to 27? Multiply. So in this case, I'm going to multiply the first denominator times 3 because 9 times 3 will give you the 27 that appears in the second denominator. So I'm going to multiply the second denominator times 3. Okay, let's rewrite then the denominators and see if we are ready to use them. So I have 3 times 9 is 27ac to the fourth, and the second denominator is 27c to the fourth a. You know, with multiplication, if I say c to the fourth times a, or a times c to the fourth, it's the same. 1 times 2 is the same as 2 times 1, and so on. So those denominators now are identical. How can I then switch or change the numerators? Remember, back in numerical fractions, if I multiply the denominator times 3, I have to multiply the numerator times 3. The same rule applies with algebraic fractions. So before I leave that, the LCD, the least common denominator, then will be 27c to the fourth a. The new denominator is the LCD. So if you are asked in the exam to find the LCD, what they're asking you to do is to find the common denominator. Okay, so let's then bring in the new denominator in our fractions, because we took out those denominators, did some work on them, but we have to bring it back to the actual fractions. So I have 27ac to the fourth, and also I have 27c to the fourth a. Well, now, what about the numerators? We're not going to keep the numerators the same. We have to multiply 3, because this is the factor I used. So I'm going to multiply 3 times the 3 times the first numerator, since I multiplied 3 times the first denominator. Okay, so 3 times 5 is 15. So it's going to be 15 on the top, and the variable part will just stay the same. That's it. So this numerator then reflects the fact that we have used a 3 in the denominator. So this fraction is equivalent to the first fraction in our problem. We did not change anything, just the looks of the fraction. The same thing, what factors I did use to change my denominator to 27c to the fourth a? And the answer is the ac to the second is the factor. Then I have to use the same thing with the numerator of that fraction to keep it equivalent. Otherwise, I'm going to be changing the problem and solving another totally different problem than the one given in the question, times a and times c to the second. This is the factor because I multiplied here 2 times that factor. Multiply on the top, and you will find that it's going to be 15 a to the second, because a times a, you add the exponents, 1 and 1 is 2, so a to the second, and then c to the second. And these would be the equivalent fractions of the original ones. If you're asked to add, you are ready to add. If you're asked to subtract, you are ready now to subtract, since both denominators now are the same. Any questions? Anything was not clear in the process of finding the LCD of two given algebraic fractions? If you have just joined us to the webinar, you are able to ask your questions by typing your question in the questions box. Okay, so let's move on to another example. Two algebraic fractions. Whether we want to add or subtract, we have to find the least common denominator, since the denominators that we have already in the question are not the same. The same process I'm going to do. So these steps I'm following, this is my way of finding the least common denominator. If you have another way to do that and you're sure it's going to bring you to the same answer, you can use that. But this is the way I do that. I'm going to write the two denominators separately, 5yz to the second, and I have 3zx. I'm going to compare both denominators. I'm going to see what's missing from the one denominator that I don't see in the second denominator and vice versa, and this is how I'm going to come up with my factors I'm going to use. So I'm going to look at the numbers. I have 5 and 3. 3 is not a multiple of 5. 5 is not a multiple of 3. So the only way that I'm going to make the number parts of my denominators the same is multiplying the first denominator times 3, the second denominator times 5. So both denominators will have a 15 on them. So I'm going to multiply times 3, but here I'm going to multiply times 5. Okay. Now the variable part. I see the first denominator has a y, the second does not. Give it a y. Multiply times y. Okay, the first denominator has a z to the second, but the second have only z. So I need a z times z. So that would make it z to the second. Now the second denominator has an x. The first does not have an x. So multiply the first times an x. Now rewrite the denominators after we have used 3x as a factor for the first denominator and 5yz as a factor for the second denominator, and see if they match. So 3 times 5 is 15, and then I have y z to the second x. That's the denominator so far. The second denominator, 15, because 3 times 5, I have z to the second, z and z times, and then I have x and y. Compare. 15, I have 15. Y, I have a y. X, I have an x. Z squared, and I have a z squared. These are the common denominators. This is the LCD of the two fractions. Now the tougher part is how can I change the numerator so each fraction stays the same. So I'm going to do the same thing as I did to the denominators. I'm going to multiply here times 3x, and I'm going to multiply here times 5yz. Then let's rewrite the fractions in their new forms, having LCD in each fraction. So I'm going to have 3 times 3 is a 9. X times x cubed is x to the 4th. And then I have my new denominator, which is the LCD. And then I'm done with this fraction. The second fraction, I'm going to multiply times the second factor. 5 times 7 is 35. Y times y is y squared. Z times nothing here matching, then z just will stay as is. And I have already changed my denominator to the common denominator by multiplying times 5yz. So I'm just going to rewrite my LCD in the fraction. And this would be how the fractions will look like if I need to add or subtract. And again, the LCD would be this algebraic expression. This would be the new denominator. Any questions? Okay, by practice, you will notice even you may not have to write out the denominator separately and then multiply and use color coding. By practice, you will know, just using your eyes, looking at the denominators and comparing them, you will know which denominator will have which factor to be multiplied to. So both denominators will have the same exact values in them and the same exact variables. Okay, another example where I have not only just, single variables appearing there, I have actually binomials in my fractions. What should I do? I need to add or subtract. I'm looking at the denominators. They are not matching. I need to work on those fractions to make them matching. So my way of doing that, I'm gonna take out the denominators. I'm gonna compare them and come up with factors that you need to use to switch those denominators to LCD for both fractions. So I'm going to compare the first fraction has a 2, the second does not. I need a 2 for the second denominator, so times 2. This is the first part of my factor for the second denominator. X plus 3 and x plus 3, so they have the same parts. But the second denominator has x minus 6, but the first does not. So I need to multiply times x minus 6 for the second denominator. So the factors I'm using here are going to be x minus 6. That would be for the first denominator. The second denominator only needed a 2. So 2 is the only factor here. Okay, so let's then put the denominators back and use those factors to change our numerators. So we're going to multiply times x minus 6, and here is going to multiply times 2. Okay, rewrite the fractions. I need to rewrite that neatly, especially the first one, so we're able to multiply 11x times x minus 6 over the new denominator is 2x plus 3 times x minus 6. And the second fraction is 2 times x minus 3. And remember, 2 times x minus 3 does not mean 2 times x and then minus 3. It means that 2 has to be multiplied times x and times negative 3. The same thing here, 11x times x and 11x times negative 6. And the new denominator is 2x plus 3 times x minus 6. Let's simplify. If we are adding, we have to simplify so we can combine the like terms on the tops of the fractions. I'm going to do that right now, but we're not going to use the combination, how to combine like terms in the top until we get to the addition and subtraction. So just want to give you a hint of it. So multiply, you need to distribute that. So 11 times 1 is 11. X times x is x squared minus 11 times 6, it's 66, but you have a minus here, so it's going to be a negative 66x. And then over the same denominator, untouched. I don't have to multiply anything in the denominator. Usually the numerator is the ones that we have to distribute things to. Look if we have anything like to combine 2x minus 6, and on the bottom we have 2x plus 3 times x minus 6, and that would be the form of the fractions if we decided to subtract or add them. This is what we need to use. Any questions? Anything that wasn't clear in that question? Okay, let's get to a self-check question. Again, those questions are not graded. I'm not gonna go over who did that question correctly or no. This is really for you. If you want to try that, I'll appreciate that you take the time to see if you're able to do that by yourself. If you don't, then when you get the recording, you can pause the video, do the question on your pace, and pick the answer and see if your answer matches my answer. What I'm gonna do, since we have lots of exponents and everything like that, some of those questions will only display when I change my screen. Is going to be A, B, C, and D with no answer choices. The answer choices are actually here in this slide. So if you want to write down your answer, your question, find the LCD of the two fractions given. These are the two fractions. And take time to write down the answers, work on the question, and then I'll change my screen where you can input your answer. So I'm going to be quiet for about 30 to 40 seconds to give you the chance to do that yourself. Okay, I'm going to change my screen now to give you the same question and then an opportunity to enter or input your answers. And it's going to be the same question, just A, B, C, D as choices. Here you go. Okay, I appreciate everyone who took the time to share their answer. So the right answer is D. This is the right LCD that you're going to use in your fractions if you decided to add those fractions or subtract them, of course. Okay, so let's actually add the algebraic fractions. So part of the addition we went already through, which is finding the LCD, but there is a second part of adding the fractions is to combine like fractions on the numerator. So we're able to put our answer on one fraction, and then we may have to simplify our answer if there are any common factors that we are able to eliminate from top and bottom. So I'm going to keep doing the same steps so we are consistent throughout the webinar. So I'm going to try to find the LCD. Now, sometimes the denominator is just easy to compare. This is x plus 1, this is x plus 2, this is missing an x plus 2, and this is missing x plus 1. What I'm going to do is that I'm going to multiply the first denominator times x plus 2 and the second denominator times x plus 1. Since the denominators again are easy to compare, I can just go ahead and use my factors on the fractions. So I'm going to do x plus 1, and I have 7a on the top plus the second fraction x plus 2, and then I have 2a. I'm going to keep the color coding so we know which ones are the factors. X plus 2 in this case and x plus 2. On the second fraction, it's missing an x plus 1. I'm going to do the same thing for x plus 1 on the top. Okay, now we need to simplify. Now we know our denominator is x plus 2 times x plus 1. That's the LCD. What about the numerators? Multiply as before. And remember, the most common mistake they see in exams that they will multiply 7a times x, but not 7a times 2, which is not correct. That's why the parentheses are around that term. Okay, so 7a times x would give you 7ax. 7a times 2 will give you 14a. I'm done with the first numerator. Denominator is untouched. X plus 1 times x plus 2. Still, I have to add plus the second numerator or second fraction. 2a times x will give you 2ax plus 2a times 1 will give you 2a. And then denominators will be x plus 2 and x plus 1. Okay, not done yet. I need to write my answer as one fraction. So since we're adding, the denominators are the same, then I am able to write my answer as is. I'm going to keep it in one fraction, write down the common denominator, the LCD once, and then write a big numerator that combines both numerators in that one numerator of my answer. Plus 14a plus 2ax plus 2a. I'm not done yet because I see that we have like terms. Remember, in Unit 1 of this course, we spoke about like monomials. 2ax and 7ax are like monomials. They have different numerical parts, yes, but the variable part is identical. And that means we are able to add or subtract. So equals to 7 and 2 will give you 9 2ax. And also I have 14a and 2a. I can combine them. 14 and 2 will give you 16, 16a over the denominator that we came up with. And that's it. That is my answer. Since I have just two monomials and then a binomial times a binomial, you can leave the answer like that since we suspect that there is any common factors. With algebraic fractions, it's a little bit tricky to decide if there is a common factor or no, but usually you will just recognize that by practice. You will know right away if you have to do any kind of factoring, if you have to eliminate anything. In this case, that is your answer. Any question? Anything that was not clear on how to add two algebraic fractions? Okay, let's move on to a different kind of addition that we may have to do an extra step to that. Okay, we have 6x over a trinomial, x squared minus 6x plus 8 plus y over another different trinomial, x squared plus 4x minus 12. Now, whether it's a trinomial or binomial or monomial in the denominator, those trinomials are not equivalent. They are not equal. This is what I should say. They are not equal. They are not identical. So we need to find an LCD. But how? The way we're going to do that, if you remember, in Unit 5, if I'm not mistaken, we learned how to factor trinomials if they are factorable. So we factor trinomials like that. So I'm going to write out the denominators separately and try to factor trinomials here, both trinomials, and see which parts are missing in which denominator, and then multiply times the factor, so we bring them together to be identical denominators. So x squared plus 4x minus 12. Okay, we used to factor trinomials like these. We need two sets of parentheses for each trinomial. We're going to have an x and an x. We have a negative and a positive. We learned, if you go back to that recorded webinar, we know there's going to be a minus and a minus. And then we look at the factors of 8. What are the factors of positive 8 that when you add them, it will give you a negative 6? So we're going to think about it and we're going to figure out negative 4 times negative 2, multiply them, will give you positive 8, but when you add them, it will give you negative 6. So it's going to be a 4 and a 2, negative 4 and negative 2. So these are the factors of that trinomial that appears in the denominator of the first fraction. The second one, similar, I have an x and an x. The signs tells me that one factor will have a plus, the other will have a negative sign. Two factors of 12, two factors of negative 12. When you add them, you have a positive 4. And that would be 6 times negative 2. Multiply will give you negative 12, but add will give you positive 4. So that would be positive 6 and negative 2. So actually the trinomials that appear in our denominators are x minus 4 times x minus 2, that's the first, x plus 6 times x minus 2. I did not change anything in the trinomials. This is only the factors of the trinomials. Now we compare the denominators. Now this has an x minus 4 and this does not have an x minus 4. This denominator needs an x minus 4. So give it what's missing times x minus 4. Now this one has an x minus 2, it has x minus 2. This one has x minus 6, but this one is missing the part that says x plus 6. Now let's go back to the fraction and do the changes to the numerators. So we're going to multiply times x plus 6 here. And this one will get multiplied times x minus 4. Now let's rewrite the fractions. So we are clear on what is going to appear on each fraction. So we're going to have to multiply 6x times x and 6x times positive 6. So we're going to do that right now. So we're going to have 6 times 1 is 6. X plus x is x squared. And then 6x times 6 would be positive 36. That's done with the first numerator. The denominator will be the LCD, which is going to be a long LCD x minus 4 times x minus 2 times x plus 6. Plus, I'm adding that to another fraction. That fraction, of course, will have the same LCD. Plus 6, x minus 2, and x minus 4. The numerator for the second one would be yx minus 4y. Now combine them in one fraction and see if we have anything common that we can combine as far as monomials. So the denominator will be written once since it's common. X minus 2 times x plus 6. And then I'm going to write 6x squared plus 36 plus yx minus 4y. I see y, I don't see anything with only a y, nothing there. Yx only 1, 36, there is no other numbers, so nothing to combine on the top, and the bottom will just stay as is. Your final answer is this. It's a huge answer, but this is your final and simplest form of the answer. Any question? Okay, want to let you know that those notes I have on my slides will just summarize the steps that we do in each type of question. So if you want to write them down on your notebook, or if you have index cards that you keep with your lessons just to, for quick reference to things, you can do that. Or if you want to just, watch the webinar and try to, compare what we do with what the step says on the side here. Next, let's do another addition problem. Now, 2y over y squared minus y plus y over y minus 3. The denominators are not common. We have to find an LCD. Okay, well, let's see what we have. We can do something here. Since I have y squared minus y, I will attempt to factor it. Maybe there's something useful I can use, or maybe my factoring is not going to be useful, but I like always to factor things that's factorable, especially if the factoring method is easy to use. So I have y squared minus y, and I have y minus 3. Y minus 3 it cannot be factored further. So y squared minus y, I have a y as a common factor, so that will leave me y minus 1. And now I'm comparing that denominator with this second denominator, y minus 3. Okay, now the second denominator is missing a y, so give it a y, times y, times y. So remember, I'm multiplying the y times everything in the second denominator. So y times y minus 3. Okay, the second denominator is missing a y minus 1. Give it a y minus 1, times y minus 1. Okay, well, the first denominator is missing y minus 3. So times y minus 3 for the first denominator. Now compare, we have a y minus 1, we have y minus 3. This is the LCD of our fractions. Let's go back to the fractions and multiply. So let's rewrite the fractions so we're able to do the correct multiplications for the numerators. So for this fraction, I used 2y, and then I have my common denominator here. And for this fraction, I used the factor y minus 3. So I have to do the same thing for the numerator. Plus the second fraction, The second fraction had a y, but I used these factors, so y times y minus 1. And then I have the common denominator, the same thing as the first one, and these are the fractions I'm adding. Simplify both numerators. So 2y times y is 2y squared minus 2 times 3 is 6y. And then over the denominator plus. I have y squared, because y times y is y squared times y, that will give you y cubed. And then y squared times negative 1 will give you minus y squared. And then over the same denominator, y minus 3 times y minus 1. Now combine these two numerators on one fraction and see if you're able to do something on that. So we have 2y squared minus 6y plus y cubed minus y squared over the common denominator. And then we can see on the numerator we have a squared, y squared, y squared. So we are able to combine these terms. 2 minus 1 is 1, so it's y cubed minus y squared minus 6y. And that would be a plus y squared, and then over the common denominator y minus 3, and y minus 1. Those questions, if you notice, they are close to be systematic. And with being systematic with the questions, you may get bored in the middle of the question, which is normal. But be careful that when you are bored, you may multiply incorrectly, when you may add incorrectly. So even though the algebra just, makes you do lengthy steps, and you have to be careful where to put the exponents, if you have to add the exponents, or you cannot combine those terms, if you have to combine the numerator or no, you have to find the LCD. It is lengthy, it is sometimes boring, but be careful. You need to do the steps correctly. So try to motivate yourself. So try to see the benefit of using those lengthy steps to find the correct answer. Not everyone is interested to know algebra, I understand, but in real life you will need algebra. If you're not going to need algebra in your everyday life, you may have to study algebra if you decided to go to a certain kind of degree in college or community college, or maybe you're doing some work that you may have to study algebra, whether you're going to use it in your career or no. Maybe it's a requirement in your college. So try to motivate yourself on why you should do the algebra work here. So that would be your final answer. Any questions on that question before we go to a self-check? Okay, so add 2u plus 3 over 3 and u plus 8 over u plus 5. Which one would be the right sum for these two fractions? In a few seconds, I'm going to switch my screen to give you the ability to choose your answer. And this question is tough because all of the denominators appears and all of the answer choices are the same. So it seems that the right denominator is 3 times u plus 5. You need to figure out the correct numerator though. Okay, I'm going to switch the screen to give you the question one more time with the answer choices. Here you go. Okay, I'm going to share my answer for this question. And the right sum for this question is A. 2u squared plus 16u plus 38 is the correct numerator when you have the common denominator 3 times u plus 5. Again, if you don't have your work correctly, it's not the end of the world. It does not mean that you will fail algebra. It just means that you need to spend time. So you can receive that video, pause, do the question one more time, try to see how we got to A. If you have a question, you can email, you can chat, you can get to the instructor, the teacher assistant, and you can get help. Okay, let's do subtraction. Subtraction really is so similar to addition, especially with the algebra. We don't have to do too much work like we used to do in the numerical fractions. But there is one trick that I'm gonna bring your attention to, which is the common mistakes that students would do with subtraction. So the same thing. LCD, you're gonna find out the least common denominator for the fractions. You will factor out you're going to factor the trinomial x squared plus 3x plus 2. And let me know if you need me to go in details on how to find the LCD and then how to switch the fractions to equivalent like fractions. I want to hear from you so I don't get too much talking about the same thing all over again. Do you want me to go over how to show how to find the LCD or directly to how to subtract? So if anyone want to type LCD, then that means I need to go over the LCD one more time. I'm just waiting for your feedback. If you want me to go over the details of finding an LCD one more time, then I'll do. If not, then I'm going to go directly to the subtraction. So let's do the LCD since Marcus wants to see that. No problem. So the same thing, the same way I'm going to do that, I'm going to write out the denominators separately. I'm going to factor out the trinomial. I have a trinomial in the second denominator, x and x. The signs tells me it's a plus and a plus. I have two factors of 2. When you add them, I'll give you 3. Of course, it's only 2 and 1. 2 and 1. 2 times 1 is 2. 2 plus 1 is 3. So we are correct on that. Look at the denominators. We have x plus 1. But here we have x plus 1 times x plus 2. So this denominator missing x plus 2, then multiply times x plus 2 to make them identical. And that's it. You do not have to change this fraction. You only have to change, in this case, this fraction. So let's rewrite the fractions and try to subtract them. So we have on the top 3x plus 1. We have to multiply the whole denominator times the factor, which is x plus 2. And then over our denominator LCD is x plus 1 times x plus 2. We still have to subtract minus x plus 2 times x plus 1. And then on the top, it's 2x. No factors were used in the second denominators. That's why we're going to keep the second denominator, the second fraction the same. So let's multiply. These are two binomials. Remember from unit 1, if I'm not mistaken, unit 1, we learned how to multiply two binomials. We used FOIL method. If you want to go back to our YouTube channel, I have uploaded the earlier units on our YouTube channel. You can go ahead and review FOIL. But for now, what we're going to do is multiply each term times each term in the second binomial. So 3 times x. 3x times x will give you 3x squared. 3x times 2 will give you 6x. And then 1 times x will give you x. 1 times 2 will give you 2. And then still divided by or over our LCD. Minus. Nothing, I have to simplify here. So let's extend that and do the minus. This is the mistake. Minus 2x. It's subtraction. I have to bring in this sign to my denominator. Minus 2x. I have to apply this sign to whatever the terms or term on the second numerator. And then try to combine like fractions. I have 3x squared, nothing with an x squared. So 3x squared will just stay on the numerator. I have 6x, and I have an x, and I have negative 2x. These are common or like monomials. So 6 and 1 is 7. But 7 minus 2 is going to give you positive 5. So plus 5x. And then plus 2 over the LCD. Okay, so that is our answer. Now, if you look on the top though, you will look and see this is a trinomial. Whenever there is a trinomial somewhere, you want to attempt to factor it manually. You're not gonna use the quadratic formula to solve the equation. We're not looking for solving equations here. We're looking for factoring. If you are able to manually factor trinomials, whether your the leading coefficient is a 1 or not 1, in this case 3, you want to attempt to factor just in case if you're able to cancel out something from the top and the bottom. In Unit 5, we have gone through an easy method that I mentioned. My teacher back in high school, like 20 years ago, she taught me that method, and it saved me lots of time. So I would like to refresh your memory on how to factor a trinomial with a leading coefficient. So I'm going to do that on the side here. So what we do, I'm going to rewrite the trinomial plus 5x plus 2. First step, I'm going to multiply a times c. 3 times 2 is a 6, so I'm going to rewrite it as x squared plus 5x plus 6. 3 times 2 is 6. Now, this trinomial has a leading coefficient of 1, and we know how to easily factor this trinomial. I have an x, and I have an x, I have a plus, and I have a plus here. Factors of 6, you multiply them, it'll give you 6, but when you add them, it'll give you 5. 2 and 3. With this method, since a is a 3, I need to bring back the 3 to my factors. So I'm going to write down the 3 here and the 3 here. The next step is to try to factor out anything there to simplify my factors. So I see that 3x plus 2, nothing to be factored out. Nothing common between 3 and 2. It will stay the same. But 3x plus 3, I can take out 3, and that would be x plus 1. And that 3, remember, we just canceled that 3. This is an extraneous factor. That's a factor that's extra. We do not need that. So the actual factors of this trinomial are 3x plus 2 times x plus 1 over our LCD, which is x plus 1 times x plus 2. Now I see the benefit of factoring. I see x plus 1 on the top and x plus 1 on the bottom. Cancel out those to put your answer in simplest form. Your answer is 3x plus 2 over x plus 2. That's it. This is the difference between the two fractions given in the original problem. Any questions? Okay, let's move on to Another problem. 3x over x squared minus x squared plus 1 over x. So I'm going to do the LCD real quick. I'd like to factor things I'm able to factor, so it's easier for me to recognize what's missing on the other denominator. Let me change my colors to be consistent. So I'm going to x squared minus x. I'm going to just write this out. Okay, factor, x is a common factor, x minus 1, and this will remain as an x, nothing to be done further. Now I see this has an x, this has an x, but this has an x minus 1. This does not have an x minus 1. Give the second denominator the factor x minus 1. So the first fraction will stay the same. The second fraction is the fraction that will be changed. Let's bring the change then to the numerators. So let's rewrite everything to be clear. 3x over x times x minus 1 minus x squared plus 1 over x times x minus 1. Well, this is in red because this is the factor. And remember, we're multiplying the whole numerator times the factor, minus 1. Okay. So I just want to bring your attention to something here. X squared plus 1 is not factorable. If it's an x squared minus 1, that would be a difference of 2 squares. But this binomial is not factorable, just in case if you are suspecting that we have to factor out this binomial. So let's get back to work. So we're going to do 3x over the LCD, but we need to multiply these binomials using FOIL. This is the method that we use to multiply two binomials. X squared times x is x to the third. X squared times minus 1 is negative x squared. 1 times x is x plus x. And then 1 times negative 1 is negative 1 over the LCD, x times x minus 1. Now combine those numerators in one fraction. So we're going to have 3x. Look at this step. This step is so important, minus, because we said we have to bring down the minus sign to the numerator. Minus what? So the minus sign has to be applied to all of the second numerator times. So minus, open a big parenthesis and write down the second numerator. And we're going to see now why this step is so important. Minus x squared plus x minus 1, and we have our common denominator. Now, this minus sign, if you remember from the last question, it has to be applied to each term in the second numerator. What does it mean? This is like negative or minus 1 times everything after that. So I need to multiply. To simplify that, I have to 3x. Negative 1 times positive x to the third is minus x to the third. And then negative 1 times negative x squared is plus or positive x squared. And then negative 1 times positive x is minus x. And then plus 1, because negative times negative is positive. And then I have to divide over the x times x minus 1, our common denominator. See if we're able to simplify anything here. I have 3x and I have a negative x. That will give me the positive 2x. I have only a 1, nothing there. The squares, nothing beyond the x squared. And then I have the negative x cubed. And that's it. Over, of course, our LCD. Now, if you look at the study units, if you have looked at the study units, some of the questions will fill 3 pages. So those kind of questions, the adding or subtracting algebraic fractions, will not be the kind of short questions that you can finish in 1 or 2 lines. they will take a lot of space. They will take a lot of variables, lots of steps, lots of division signs, lots of things that if you do not understand how they got that from, you'll be so overwhelmed by the amount of writing that you have to do for one question. So Marcus is asking about the x to the third. Is that x to the third? So this is x to the third. This one is x to the third, but it has a negative sign because see the sign of the x to the third, I cannot just, delete that or make it a positive. It has to come or go over with its sign. So it's a negative x to the third plus x to the second plus 2x plus 1 and then over the LCD. You will be receiving the recording too of the webinar. If you're trying to write after me, it's going to be too much work for you guys. Wait for the recording and you can watch it as many times as you want. Let's look at a self-check. 2u over u squared minus 1, u squared minus 1. So that should click something in your head. U squared minus 1. It's a binomial, but it's a special kind of binomial. From, you want to subtract that fraction from u plus 2 over 4 times u plus 1. Now, the wording of the question is so important. Subtract this from that. Which fraction will appear first in our problem? What minus what? How can I arrange my question? So think about it. If I have 5 oranges and I'm gonna tell you, I'm gonna give you 2 from my oranges. It's the same as saying 5 minus 2. So the term that's after the from would be the first term and then a minus sign and then the second fraction. So just want to clear up the confusion if you don't pay attention to the wording of the question. So I'm going to be quiet for a few seconds, give you the chance to work the problem, and then change my screen. Okay, I'm going to give you the question one more time and the answer choices. And I hope you had enough time to write down the question and work out the question. I'm just waiting for everyone to have a chance to input their answers. It makes a difference when you have a real person you speak with, you input your answers, you get a feedback. It really adds too much to the learning process. Okay, so I'm going to share my answer here. The right difference of these two fractions, the second fraction here that appears on the screen minus the first here would be C. C is the correct difference. C is the correct difference. And this trinomial is not factorable. How did I know that? Factors of -2, when you add, it will have a -7. Is that possible? No. The only factors of 2 or -2 would be a -1 and a +2 or a +1 and -2. And in both cases, they will never add up to a -7. So this trinomial is not factorable. So that would be your final answer. No, um, no simplification you're able to do further than that. Any questions? Anything that was not clear throughout the webinar that we went through, any of the questions that we had done, or the process on how we do things, the LCD, adding or subtracting. So far in this webinar, we looked at how to find an LCD, the least common denominator of two given algebraic fractions, and how to use that to add and subtract unlike fractions. Now, the second section of my webinar, I want to go over how can you prepare for the exam, because that is important too. So you need to read your study unit. You cannot just depend on, this webinar only. You need to read. You need to do things using your hand, your pen, your paper, your notebook. You cannot just watch things are done, especially in math. You have to practice them yourself, do mistakes and learn from that mistake. And that's how you avoid those similar mistakes in the exam. You can rewatch that webinar. You can watch some recorded videos are there on the course. I think there is one about FOIL if you want to refresh your memory on FOIL, and there are a couple of other ones there. The self-checks or the practice exercises within your unit are important. They reflect how hard or easy or what may the exam have as far as those topics. So it is a good idea to go over them, do them yourself, compare your answers to the answer key given for each question. And these answer keys are provided to you, so you are able to assess yourself and see when you are or maybe you're not ready for the exam. Also, an outside resource, I was asked before to provide an extra resource that students can go to have more, learning and videos, would be khanacademy.org. Go to subjects on the top left, click on subjects, click on Algebra 2, and then click on rational expressions. Now, rational expressions are that's like another name for algebraic fractions. And from there, you will see a topic that says adding and subtracting rational expressions. That's not mandatory. If you don't want to go there or watch their videos, you are not required to do that. Also, you can call the school on those times on weekdays. You can schedule an appointment to have a one-to-one conversation with your instructor or teacher assistant. You can text your brief questions to that number, and you can type in learn if you want an academic support with math or with any other subject. You also can email your instructor, and with the email I thought to bring you screenshots of where to go. So each students may have different looks of the accounts. The courses are so identical, but the looks of things in your account may differ. So if you have that kind of account, you want to just follow those steps to send an email. If you have this account, you want to follow those steps to send an email to your instructor. And that's it. If you have any general question or specific question, I'd like to answer them before I conclude my webinar. Okay, if you cannot think of any questions right now, you still have the opportunity to communicate your questions through email, chat, or text messages or phone calls. I would like and I would love if you are able to take a survey, only three questions, brief questions about how did you think this webinar was useful, or what should have been done extra in this webinar, or if you're satisfied with the webinar. It's only three questions, and even registrants who did not attend today will have a link to the survey. So I appreciate your input, your feedback. It will help me myself to improve my webinars, and also will let me know how did I do during this 1 hour of instruction. I wish everyone the best in the exam. Good luck.